Hello, 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 everyone. How's it going? I hope you had a nice break. Uh, I'm sure it wasn't a long one, but yeah, I guess it was all right, right? But 55-minute break, I would say, kind of, and gives enough time to have lunch, dinner, uh, and get back, get back to our journey into the world of finance with Python. And now this one is going to be a bit more, it will build upon what we learned, but it would go kind of beyond those things as well. Okay. We will start building things with the libraries, some data science libraries that we have, which are very powerful. Example, pandas, example, numpy. And once the time comes, I will also show you uh, some neat little things about it. I will show you how to do plotting of graphs because I think that is the most important part of anything. Okay. If you can visualize things, it is good. Okay. And but before we get into it, for anyone who is joining for the very first time, welcome. And in the previous session, that is the first session of this Finance with Python, the part one, we went through some really basic of Python, which was covering like what are variables, control flow statements, uh, data types, list dictionaries, all those things, writing functions, writing loops, uh, and combining our knowledge of looping with control statement like if else, and printing out stuff which was just like pretty cool, I guess. Okay, that's all I can say right now. I have pushed everything. So if you're joining me for the very first time again, then you can find all the code that I have done so far on this GitHub repository that I have. Okay. Uh, and if you want to follow along, then you can fork this repository on your account, okay, on your GitHub account, then do a clone of it on your local, make changes. But anytime I make a change and I push it to GitHub, you can always sync your fork with it. Okay. So you can sync the fork or like sync your changes with mine, anything that I add or remove. Okay. So that is some quick overview of part one. And now we will move to part two. But before that, uh, may I kindly request you all to register for the session if you have not done it yet. The link is in the chat. Okay, so this one should help you register for this part two of the session. Do register because that's how it helps you, it helps me, it helps MLH. Okay. And finally, one last thing before we begin coding directly is when I went uh, towards the end of previous session, I had requested you all to fill the feedback form for session one. So I hope you did that. If not, towards the end of this session, the session two, I will share the feedback form again, and I would appreciate if you all took just 5 minutes of your time to fill it quickly. Okay. So I think that is good enough introduction about session one, like recap of session one. Good enough introduction about the project. Uh, Also, I did not introduce myself, but I am UT. I'm a coach at MLH, and I just love to take these sessions to teach people what I have learned over the time. Uh, so it could be something new for you. It could be something repeated for you, but at the same time just enjoy it. If you already know all of this, then anyone who doesn't, help them out. So remain in the stream, uh, check the chats, reply to people who are asking questions if I'm not able to see those questions quickly. That ways you can impart knowledge to others. Okay, cool. Now let's get into it. Now, step one is to restart the Jupyter notebook. So the instructions are in the README, but if you're joining me again for the very first time, then let me repeat that. To open a Jupyter notebook, you do a Jupyter Space Notebook, and you can shut a Jupyter notebook from two places. Okay, you can go in. Excuse me. So let's say I was in, no, not this file. I was in here. Okay, I can go into file, close and shut down the notebook running because it's technically a server running. Okay, uh, you can go in the running part and shut down all as well. Okay, so that is one thing. Next, this is opening a notebook. We want to open Jupyter Lab, which is notebook, but just better. So I'm going to close the notebook and I'm going to have the session 1.py Jupyter Lab. Okay, you can shut down all from here, and to shut it on your system you can do Control C to basically force close something. Okay, force quit a server. uh, okay, now session 1 is done. I'm going to go ahead, go back one folder, and right in the root I'm going to create a new folder. Oh, sorry, this one, new folder, and I'm going to call it session underscore 2. That ways we can segregate what we learned in session 1 versus what we learned in session 2. Once I go in that, I am going to create a new notebook. Okay? So to do that, you can click on this plus and click on this Python 3 IPy kernel. Before we went uh, on the break, like in the first session, I told you the kernel is basically the engine that is going to execute our code. There could be multiple actually. In our case, it's Python. So I click on that. Instead of untitled, I can click here and call it session dash 2. Okay. And I can close this by clicking on that folder. And you can save this by clicking here, the save icon, the very nice floppy disk. And if I go back, now I should have a session 2 folder created on my VS Code. And inside that, I can find the IPy notebook, which is empty right now. Okay. So this is just to ensure that things are in sync, things are saved, stuff like that. Also, I realized the face is not exactly visible and I'm teaching something. So for the timing, and you don't have to do this because it hurts your eyes probably sometimes, I'm going to go light mode. Ah, too bright. But currently, the what's the word? It's too dark because it's raining right now. So yeah, and the light is not helping. Looks like. Okay. Anyways, let's move ahead. So what are we going to do in this session? As I said, we are going to work with data science libraries like pandas, numpy, matplotlib. So let's start by importing libraries. So step one, to import anything, you do import. The syntax is import, name of the library, which is pandas in this case, and you can rename it. Okay, and this is not really required. So we'll look both ways. I'll also want to import numpy, and I will also want to import matplotlib. Okay, and if I do a shift enter, that should execute this whole cell. Okay, finally it imported. Once you see a star here, that is when it's in the execution mode, and when it gives the number here, that means it has finished execution. Now we can see the version of the libraries that we imported by doing a very quick print. I'm going to use f strings, and I will say pandas version, and then I'm going to create a curly brackets and then write pandas dot underscore underscore, and you have the option of version and then underscore underscore. So if I print this, then it should tell me, oh, the pandas version is 2.2.3, and this version is actually exactly what is stored in our requirements.txt. Okay, so 2.2.3, when we created this requirements.txt using pip freeze, if you remember. So similarly, I'm going to copy this and I'm going to paste it two more times. The second one would be numpy version, and the third one would be matplotlib version. And this one, of course, would change to numpy, and this one would change to matplotlib. Okay, and these are the versions that I am importing in this. Okay, writing pandas, writing numpy, writing matplotlib. You saw how good I am in spells, right? So I don't like to write the whole thing. So in Python, you can kind of rename a library import. So I'm going to give it a short name, and this is a standard across all the GitHub repositories or anything that you see. So in our case, I'm going to say import pandas as PD, import numpy as np, and matplotlib. This is very uh, interesting. Why? Because in case of matplotlib, you can actually also go one level deep and say that I want specifically what do you call it? The plotting part of it. Okay, yeah. So in matplotlib, inside that, there is another folder called as .py plot, and I want just the plotting part of matplotlib, nothing else. So I can go import pandas as PD, import numpy as np, and import matplotlib.pyplot, which is one level nested inside matplotlib, and uh, da- and import it as plt. If I do this, this works. If I do this, it still works. But I can now actually do pd.version. I can do np.version, and I can do plt.version. And if I run this, the first two work, but plt.version actually does not, because this is a nested thing. Okay, so we are going one level inside matplotlib. The version property exists on the matplotlib and not the pyplot. So this one I'm going to keep it as this. Okay, cool. So this is our imports done, and our like version printing is done, which means that the version printing is specifically because we want to see if it actually has been imported or not. Okay? So it's a neat little trick, you can say. Now, no one has actually asked me in the chat yet, what are these libraries? What are they used for? I keep saying things, but what is it? Okay. So let me share some documentation in the chat. The first documentation that I'm sharing is of NumPy. The second one would be of Matplotlib. So there you go. And the third one would be of Pandas. Okay, I think that's good. And now let's dive a bit into what these libraries are. So, example, the first one is NumPy. Okay, we are using the 2.2 version in our code as well, as far as I remember. 2.2.2, yes. So, NumPy, it is a numerical Python library, open source library, which is used for data science and data engineering. Now, the fundamental, or like the most important part of NumPy is that it allows you to do mathematical calculations quickly, okay, really quickly. So, and the structure is almost same as a list in Python. Okay? The only difference is when we saw lists earlier, we saw that you could add an integer, you could add a floating, you could add a string, all of those inside a list. You could also add booleans actually inside a numpy array. Sorry, inside a list. Okay, so that means like you could have multiple kind of things in a list. But in a NumPy array, you are expected to ensure that the data type is the same. So if it is an integer NumPy array, like all of the terms need to be integers only, no floating points. Similarly, if it's floating point, all of them need to be floating. You can have strings, of course. Actually, no, you can't. You won't do mathematical operation on string NumPy array. So that like let's not get into that. Uh, the next thing is when you have one single square bracket and you have terms inside it, that is a single dimension or one dimensional array. Okay, NumPy array. Uh, so this is a confusion. Uh, in Python it's called list, but in NumPy it's called arrays. Okay? So you can have one dimensional, but you can have nested, like square bracket inside square bracket inside square bracket. You can go as nested as you want, and that is how you end up with n dimensional arrays. Okay, more dimensions added to the NumPy array. So like you could have one, and you could have like nested two-dimensional arrays, and so on and so forth. You can go as much as you want. So it is kind of like a basis of everything right now in Python. Okay, you have a lot and lot of uh, methods available on NumPy. So you could do things like creating, arranging, reshaping, as you can see. Uh, let's say there are lot of functionalities available for the Python part. So that is our NumPy. The next one that I shared was pandas, I think, right? Or matplotlib. What did I share? I shared wrong thing. Matplotlib. Okay. So matplotlib. Let me show you what is matplotlib. Hopefully you're opening it along with me. So matplotlib. It's too light, too bright. Uh, okay. So matplotlib, as the name kind of suggests, I would say, it is for plotting, mathematical plotting, kind of figure plotting, whatever you say. So this helps you plot things on your machine. Okay, you can create graphs from data. So see, these are the things that you could get. So number one is there is this whole grid that gets printed. You have a title. You can set the y-axis ticks. Okay, so minor ticks, major ticks. You can have a y-axis label. You have a x-axis minor ticks, major ticks. The label, then you can have markers of what you're plotting. You can have like different colors, you can have line, you can have a grid, you can have a legend, and this whole thing is called as a figure. So it's not much, but like as in like it's not much to learn, but once you start plotting things, you see how deep you could get. Okay? So you can like change the color styling, what you're plotting, how you're plotting, different colors like dark mode, light mode, all those things you could do with this. Gives you a very simple library but very powerful library with matplotlib. And the third one is pandas. Okay? Now, what is pandas used for? That is the first thing. Okay, you see the documentation was built on the same platform actually. For this one and this one. Yeah. Uh, okay. So what is pandas? So pandas is working with tabular data. So you can think of tables, or very simply, think of Excel. Okay, think of Excel, think of Google Sheets. What you get there visually is what Pandas allows you to do in terms of code. And again, it is powerful. Okay, it is very powerful. It's quick, so it allows you to visualize data, like see the data in tables. You can go through things, you can focus on a specific cell. Okay, you have your rows of data, you have your columns, column names, and this and that, a specific cell of data. uh, but in Pandas, this special data type is called as a data frame. Okay, now you can create a data frame out of CSV files, JSON files, not sure about HTML. I don't remember exactly. As in like HTML table. I'm pretty sure that's not exactly possible because of UI versus this. But these two things, Excel. Uh, okay, so at least these three things definitely come to my mind. Oh, there we go. CSV, XLS, Parquet. Oh, HTML is possible. Ah, interesting. I forgot about that. HDF5, JSON, SQL, so many. Okay, you can read these files, import these files, convert them to a data frame, and also export them out into different formats. Okay, uh, yeah, that I think is good. You can use pandas to plot, but with matplotlib. Okay, so you just think that matplotlib to the rescue for any of the plotting. We have different plotting libraries that are available, which we will actually explore as a part of our sessions. Okay, example one of them is hmm, Plotly. Yes, that is one thing that we'll explore. And when the time comes, I'll show it to you. So this is a very quick introduction about these libraries. Uh, Another powerful feature is when you have a tabular data, you want to know the statistics of the data. Okay, if let's say you have a data of numbers, like let's say stock prices of Apple, stock prices of Tesla, stock prices of Amazon, Microsoft, Google, all those things, Meta, whatever. You want to calculate what is the mean or like the average, what is the median, what is the mode. You want to calculate a sum of everything in the column. You want to calculate the cumulative sum of things. You want to calculate what is the lowest. You want to find what's the lowest value, what's the highest value, what is repeated across the data. So these are things, like these are questions that someone can ask you when you are showing your data to someone, like you are doing a presentation and they want to know, okay, what's the total, what's the average share price of Apple stock over last 1 year, over last 3 years, over last 10 years. So these things are, you could do it two ways. One thing, if let's say this is an Excel, then you select the whole row, find the sum. You select particular date ranges, find the sum. Or you can use pandas to actually calculate these things because it has inbuilt methods for it. Okay, you can do like dot sum on things. You can do like dot average, dot like not dot average, dot mean. Okay, uh, all those things are possible with pandas. So it's really powerful tool. You can say it's Excel, but much better. I mean, Excel kind of right now allows you to add Python code in it. So I wouldn't say much faster, but it's on par with everything that Excel gives you. Okay. And in a simple syntax. Okay? That's important. And that is a good enough introduction of all the three libraries that we are going to use. Now let's get into it. So step one, I'm going to convert this code cell to a markdown, and we will learn about essential data science libraries like pandas, numpy, mat, and matplotlib. Okay. and I'm going to move this uh, on the top on the first one. So this is done. This is done. Next is, let's create a simple data frame with pandas. So to do that, uh, what we will do is, let's create a dictionary. Okay, you know a dictionary now. We have seen this already as part of our session one. So we create a list of stocks: Apple, JPM, which is JP Morgan Chase, and MSFT, which is Microsoft. Then we create another key here called as price, and we create the prices, which is like 150.75, 100.50, and 200. Okay, example. And then we create the amount of shares that we own of these. So let's say 10, 15, 25. Okay, so this is good. And now the next step would be to create a data frame. Now the syntax, normally what you would find across on different GitHub repositories and stuff, is the short form for data frame is DF. We imported our library as PD, and then if you do a dot, and if you do a dot data frame, and then of this particular data, okay, this data variable comes right here, and then we can do a print. I'm going to add a backslash n saying simple data frame, and actually I'll put it right below this, print df. Let me run this, and there we go. So for this data dictionary that we created, uh, let me also print the data dictionary. Print f-string data dictionary, and then inside this I will create data, and I'll do a backslash n so that there's a new line after this. So this was our original data dictionary, and this is the data frame, much more like looking like a table. Okay, you won't disagree with that for sure. uh, it created this another column, which is the index column. This is the zero, this is the first, this is the second row. The keys, actually the stocks, price, and shares, they went in as your column names, and the values, they were mapped that Apple 150.75, 10 shares, JPM 100.5 price and 15 shares. Okay, as you can see, MSFT 200, but that, remember I told you that all the data type need to be same. So it actually converted it to 200.00, a floating point, and 25. What if I own like 25.5 shares of this? If I do this, it converted like, before this, just remember everything was a integer in this column, but if one of them is float, it converted everything to float. Okay, so that is what you need to notice. Sorry about that. Okay, so that's how we create a very simple data frame. And also add a new line here. Yeah, much better looking, I guess. Okay, cool. uh I spend too much time in cosmetics. Yeah. Okay, anyways, so that should give you an idea of creating a very simple data frame with pandas. Any questions so far, anyone? Either I'm teaching really well or no one is understanding anything. So these are the only two possibilities for the silence. Okay. I'm going to take it as I'm teaching really well. So thank you so much. Okay, let's move on to the next bit. Also, I feel like I'm coming in bit between the screen because I always have to scroll up and stuff. I am actually going to remove myself from screen so that you can focus solely on the screen. Don't worry, I'm here. Okay, so what's next? Next, we want to use NumPy. Okay, so we have created a simple data frame. Let's leave that. Let's go and create a NumPy array. Use NumPy for numerical operations. Okay, let's see this very quickly. So let's say uh, we create a prices. Now there are, like, you see the prices that we created here. This is a normal array. Okay, not too bad. Fine. Uh, but very simply, if we have to understand what NumPy does better, you can think that NumPy arrays are faster, they are more efficient, memory efficient. But for a Python list, it is more flexible. NumPy is not really flexible. It is very much all about ensuring that the data type is same. It's about like not mixing different data types, uh, and more importantly, it is quicker and, like, mostly used for any mathematical operations. So, example, if we create a list here, to create a NumPy array out of it, we can do NP, where NP is the NumPy that the library import name, NP dot array, and then inside the round bracket, we do this. Okay. Now, if I want to create an average price of all of this, then I can use NumPy and do a mean, okay, for all the prices. And then I can print that out saying that average stock price. I'm going to use f strings here and dollar, and inside this I can go average price, and I can also say that calculate in two decimal places, so dot 2f. Okay, if I run, this is the average price. Now if I have more things here, 150.75, uh, let's say 152.30, 148.90, 151, and then 153.45, and 164, 159.99. Also, let me print the prices array. F strings. There's a session here, and I can go like prices here. Okay. And if I run this, so this is what I end up with. So prices, it looks like this. There is a space in between. And if you notice the 151 that I had added, it has a dot after that. Okay. So that means it converted to a float. And this similarly for this and this. If I do like 151.0 and 164.0, then that's what we end up with. Zero is removed. So everything gets converted to a float. Uh, Remember, same data type. That's important. Uh, Average price that we calculated, and this is what we end up with, 154.34. If I go like dot 1f, then 154.3. Dot 3f, and that should be 154.341. And if I remove all of that, this is the actual average that comes out, like actual decimal places that comes out of it. Okay. I think this is good enough for NumPy. We saw pandas, we used NumPy. Now let's use matplotlib, okay, to plot something. So plot with matplotlib. Okay. So as I said, matplotlib is a popular library for creating any static, interactive, or animated plots. And in our case, we'll use matplotlib to create a very basic, very basic line plot or a line chart or whatever you call it. Uh, yeah, of the stock price that we have. Um, okay, let's start. So step one, we first decide the size of the figure. So we use this input plt dot figure, and inside this we define the fig size. So I do fig size equals, and you set uh, the width and the height. Then we can do plt dot plot, exactly what to plot. In our case, I want to plot this prices numpy array that we created, and then you can define the marker. Okay, so marker is used to show the points on the plot. So you can show a marker with like a dot, a o, a s. Like we'll try all of them. Let's say I start with a simple o. Then the line style, I think line style like this. So line style, this is to show the line style. So it could have a single dash, double dash, underscore, colon, all those things. So let's say in our case, use a single dash. And then the color, which should be very simple, the color of the line. So in my case, I'm going to say it should be blue. Then I can go like plt dot the title of the plot. Okay, so I'm going to give the title stock prices over time. Then plt dot x label, and basically on the x-axis, what should be. So I'm going to say it is actually time, but we haven't actually decided time anywhere, like added any time anywhere. This would be just arbitrary units. Like assume that there is a time. That's what I'm saying. plt dot y label. So this is not an instruction to matplotlib. This is what will be plotted there. Like sorry, written there. On the y side, y axis, it is actually price, and I want to use a grid. So I'm going to say plt.grid true, and to plot something finally you do plt.show. Okay, there is a error in my code. It says attribute error, got an unexpected keyword argument market. Did I re Oh yeah, I instead of writing marker I wrote a market. So but it still created a box. Okay, now if I do this, there we go. Stock prices over time. This is the price, and this is time. Since it did not have a y-axis, it ideally just randomly started with 0, 1, 2, 3, 4, 5, 6. Okay, and the blue line and the marker. So if I don't want this marker, I can use a S. I want a double dashed line, and I want this to be red. There we go. Okay, S is for square. Uh, I think there is also another one. Uh, you could use a dot, I think. sure if underscore works actually. Yeah, underscore doesn't. It has dash, double dash, dash dot, and colon. Dash dot. There we go. You can have a colon, and that's what we end up with. Marker O in this case. Perfect. I think this is good. If I do a grid false, the grid is gone. And this is what we end up with. Okay. So a very simple plot of stock prices that we had from the NumPy array. Okay. Any questions so far? I think this was a good intro about NumPy, pandas, matplotlib. Excuse me. Okay. I was waiting for any questions. Doesn't seem like any. So, and other things that I could show you in NumPy actually. Yes. So, mm, thinking right now. So give me 1 second. Mm, Okay. I told you like you can use NumPy for many more calculations. So one thing that we found was average. Okay. What else we could do? We could use NumPy for summing up things, or finding the min, or finding the max, median, percentile, standard deviation, all those things. Let's like quickly go through it. I will say start with price sum, and that is going to be np dot sum of all the prices. Okay. Next one would be, should also print it out. So print f string uh, sum of stock prices, and I'm going to go that it's a stock price. It's in dollars. Dot price underscore sum, and I will again say that this is dot 2f. So this is the sum of all of these. Uh, Other things include, like, let me just copy paste this a few more times. So we did a price sum. You could also do a price min, which should be just that min of price. And I'm going to copy this one here, min of stock prices. Similarly, you could do a price max, of course, and this would be just dot max of this. Max, and price max goes here. You could do median. Okay. Okay. Median of all of this, and I can say median would be this. Uh, let's print these things out. So this is everything that we got. Okay. Average sum. What is the minimum? Is 148.90. What is the maximum? It is 164. The median is 152.30. Uh, Hopefully, median is like, if you remember median. So median is arrange everything in ascending order, find the middle. That is your median roughly. so that you can find standard deviation. Okay, that's an interesting one because that is a concept that we'll use next. Standard deviation. So price underscore standard deviation, that is equal to np dot standard prices. Okay, and I'm going to copy this one and I'm going to paste it. Standard deviation of stock prices is going to be price standard dev and this thing. Okay, this is the standard deviation of the stock prices. So what is standard deviation? Now this is a concept. So let me come back on screen for it. So standard deviation, what does this mean? Like let's start with first the mean. So the mean is the uh, average of all the values. So how do you find the mean? You do a sum of all the values and then you divide it by how many things exist. So in this case, when we were finding the average, we were doing like this plus this plus this. So 1, 2, 3, 4, 5, 6, 7 things. Sum of all these 7 things divided by 7 gives us the average, right? That is the mean. Then the standard deviation is the measure of how spread out these values are. But for that, for you to understand standard deviation, you have to first understand variance. So let's go back, sorry. Mean, it's the average of all the values. The variance is the average of the squared differences from the mean. Okay, so that measures how spread out the values are. Example, and you don't have to write this, but let's say if you have three values, 1, 2, 3. So these are your three values. So this is multi-line comment in Python. So my values are these. Okay, 1, 2, and 3. So what will be my sum of all the values? It would be 6. What would be the average of all these values? So that would be 1 plus 2 plus 3 divided by 3. That should give me 6 divided by 3, that is 2. Okay, so now that is my average or the mean, whatever you call it. What is my variance in this case? So my variance, as I said, is the average of the squared differences of the mean. So in this case, to find the variance, we will do 1 minus this 2, okay, the average. So 1 minus 2 squared, so raised to 2, plus 2 minus 2 squared, plus 3 minus 2 squared. And what does this return me? So 1 minus 2 would give you minus 1. Minus 1 squared should be 1. Plus 2 minus 2, 0. 0 squared would be 0. Plus 3 minus 2, 1. 1 square would be 1. So this actually returns me 2. Okay. So the variance in this case is 2 again. Now, standard deviation, this is basically the square root of the variance. Okay, so I'm going to write like sqrt of 2, and this is approximately what, 1.41 something something something, right? So that the variance and the standard deviation. So why do we find this uh, variance and standard deviation? So in terms of stock prices, you have to think that the stock prices, like today's stock price is not independent of each other, like the other things. So the price of stock today is influenced by the price of stock yesterday. Okay. So in that case, like let's say if the price of stock today is 105, then we check the price of stock yesterday. If it was 100 or something, so that means today's price was influenced by yesterday's stock price. It rose or it fell down depending on yesterday's stock price. Now, in real life, stock prices are influenced by many other factors, right? There's company performance, market conditions, any news, any gossip, or anything that's going on that influences the price. Uh, yeah. And by using these mathematical formulas, like how much variance, how much is the variance, how much are you deviating from the average is the standard deviation, uh, tells you if it is very volatile, if the change is too much or the change is too less. Those things that you get to know. You also use these things to calculate, let's say, the cumulative sum. Okay, a cumulative sum is used to simulate the change in stock price over some time. Okay, as I said, stock prices are not independent. They are dependent on, let's say, yesterday's stock price. So if the stock price today is 100 and the stock price tomorrow is 105, the cumulative sum would be 205. And if the stock price after that day, like day after tomorrow, is 110, so then it would be 100 plus 105 plus 110, 315. Okay. So we also use like these cumulative sum. It helps us simulate this change in stock price. And to calculate that, you have to know what is the standard deviation, what is the variance. Uh, you have to, yeah, do like know a lot of things. But this is some theory slash logic behind these mathematical, like use of these mathematical formulas, not logic, but use. Okay. Next thing that I want you to do is actually let's create a very simple mini finance project. Mini, sorry, hello finance project where we simulate and plot a random walk. So this is what we are going to do. But for this, you need to first understand what is a random walk. Okay, it is a very simple model for simulating stock price movement. The assumption in this is, actually, let me make it normal. The assumption is that price changes are random and unpredictable. Okay, this is an assumption. If you want to read more about this, you can actually find some nice information on Wikipedia. So let me show that to you. There we go. And the link is in the chat. So this is, yeah, some theory about random walk. You don't need to go through the math of it. All you need to do is read more about this one. Okay, this should be good enough. Okay, so random walk, and yeah, let's. I'll also add that link here. Read more about random, random walks. Yeah. Okay. Perfect. So that's our this description. Let's start with random number generation. Now, NumPy, powerful enough, actually helps us create random numbers. Now, every time we run this, I don't want the numbers generated to be different. So that is why I'm going to use a seed. Use seed. This ensures reproducibility. same random numbers each run. So random numbers, as the name says, it's supposed to be random. But if I use a seed, that is like saying that this is your basis of generating the random numbers. So if I run this again and again and again and again and again, it will generate the same random numbers. Okay. So that ways my graph will look exactly the same every time. It will generate random numbers, but the same random numbers. So I can say if you want truly random numbers each run, remove this line. Okay. So I have set a seed. Now let me create a variable random underscore walk, and that is equal to np dot random dot normal 0 1 100, and then we want to find the cumulative sum of it. So dot this. Okay. So two things here. So number one is normal. Okay. What is this? So a normal distribution. Let me think. If you have to understand a normal distribution of numbers. Okay, it means that over an average, it's going to be similar or symmetric. Okay, over a big average. So actually, you can find more about the NumPy normal here, and the link is in the chat. So a normal distribution is how do I explain this? Very simply. Let me think a bit. I think a Wikipedia link should be good enough. If I can find a very quick Wikipedia link. Yep, there we go. Okay. Yes. So a normal distribution, also called as Gaussian distribution, what it assumes is that over the time, or like from your mean, okay, the change is kind of same across. Okay. And a normal distribution is kind of found in most of the places. It's very popularly known as the bell curve. You might have heard that most of the things fall between this center, and there are very less things that deviate from the center too far to the left, too far to the right. Most of the things are in the center of the bell curve. So this is, yeah, I think this explains it a lot. This is your average. Okay, most of the things are within a acceptable range of average. Okay, and very few deviations happen very far from the average. So when we actually use, like, why do we use actually this normal distribution? So in our case, where is it? Yes, here we are using normal distribution because we want to generate. Okay, we want to generate you can say an array of numbers where there, do you say, where the average, sorry, where the mean. Yes, I think the mean is going to be 0 and the standard deviation is going to be 1. And if I can find this, mm, yeah, the mean is going to be 0 and the standard deviation is going to be 1. And I think I actually shared the link to the, yeah, this one. Yes, there we go. Okay. So why are we doing this? Because when we generate random numbers, the random numbers will be some positive, some negative. So overall, we want to ensure that the average of all the generated random numbers are nearly 0 and the standard deviation is near about 1, so that they are not very far from the average, very uh, down, very far on one side or the other. How does this help us in stock price? A stock price for most of the stocks would actually follow this normal distribution where the prices of today, tomorrow, and yesterday, they won't be so far from each other that yesterday it was 0, today is 2000, and tomorrow is, I don't know, like 150. Next day it's like 2500 or something. You have a very normal distribution between yesterday's price, today's price, tomorrow's price. Okay. The deviation is not too far generally, but in real life, that is not exactly what happens always. In real life, you have things that could go too much up, too much down, depending on the market factors, depending on the news, depending on the financial outcomes or anything. But in our case, in terms of stocks, we would assume that the fluctuation is not too much between one number and the other. Okay, I think, yeah, that should help understand what is happening. Uh, so that is np dot random dot normal, where we this first term is for at the mean of it should be near about 0, as close to 0 as possible. The standard deviation should be as close to 1 as possible, and we are generating 100 random numbers. Okay, and once done, let's print the random underscore walk. And this is what it generates, the 100 numbers. Excuse me. So some positives here. Then it goes into generating these negative numbers. Now, if I want to find the mean of this, okay, so mean of the walk, I can do np dot mean of this random underscore walk, uh, and also the standard deviation. So standard deviation of the walk would be np dot standard random underscore walk. And let me also print this f strings mean of random walk, mean underscore walk, and I want like two decimal places for 2f, and I'm going to copy paste this, and this is standard deviation of random walk, and that would be this one. Yep, good enough. So this is the mean of the random walk, and this is the standard deviation. We asked it to be as close to 0 as possible. Uh, Not really happening, but this is the best. If I remove this and if I run this and I do this, this is what I get. Okay. If I do this again, this is what I get. If I do this again, so it changes every time. But if I use the same seed, in that case, the output would always be the same. Okay. Yeah. So that's our numbers generated. Now, if I don't want to see like all 100 numbers, like let's say I want 1,000 numbers, this would be too big of the output. So we can actually plot only first 20. We can do that by doing first 20 values of random walk is, and we could do something like in curly brackets random walk, and I only want the first 20. So then in square bracket I can go like from 0 to 20. So this ways it only gives me the first 20 values, and I want a backslash n here so that the text is in one line and the values in the other. Okay. Now, if you want the first 20, actually you don't have to specify the 0. You can go without that and that should work the same. But for the understanding of like for later understanding, I would keep it as is. Okay. So now for 1,000 numbers, oh, this, let's say for 100 numbers, this is what we end up with. Okay. Now what we want to do is plot these values. Okay. We did the whole thing for plotting the values. So now we can do just plot dot plt dot figure. First specify the fig size, and that is fig size equals 8 comma 4. Then plt dot plot the random walk. I'm going to use the marker as dot, the line style as dash, and the color as what's the color? Red, right? So now let's go with green. The title. So what is this talk about? What is this plot about? So this is a simulated random walk, or like basically stock price simulation. Then the X label. This is actually time in days. Okay. The plt.y label, this is actually the simulated stock price. And I'll of course show a grid because I think that makes it easy to see. And plt.show. So now if I do this, this is the simulated stock price. So on day 0, it was somewhere here, and that somewhere here is 0.49. Okay, slightly above 0. Okay, so that's what this is showing. And then it goes to the next day 0.35, which is slightly below. Then it goes to 1.0, which is above, and similarly so on and so forth. And this is a cumulative sum. So if I can actually show you random walk no sum, and that is just np dot random dot normal 0 1 100, and print this one. So these are the values. So if I actually plot that one, I will copy this one, paste it here. One thing that I want to do is the no sum one. Excuse me. So this is not the random walk. Simulated random walk, no cumulative sum. Okay, so you see, like, based on this chart, what's the difference exactly? Now this one is basically, okay, saying that the stock price of the next day depends on the stock price of yesterday. So depending on that, this is the stock flow, the price flow. You can say that for the first 20 days it was up, like slightly started going down and then going down, and then, yeah, this is more of a actual stock price, how it looks. If you don't do a cumulative sum, then what you see here is this very sharp up and down, and this is not exactly what a stock price would actually look like. So that is kind of the difference that you see between a cumulative sum, which simulates a actual stock price, versus a random, like a sum. Sorry, a graph of where you're not doing the cumulative sum, where you're saying that, oh, it does not depend on yesterday's price, so just plot everything randomly. So this is a wrong plot. I will also say add this. Okay, so these are the two things. Now why did I do this cumulative something? Because once we actually start plotting some real data, you will see that the real data is looking more and more like this cumulative sum. And this was to introduce you to this concept, or this idea, that stock prices are not independent of yesterday's price. It depends on what happened yesterday. uh, One last thing, instead of 100, I want to do it over, like, let's say 1,000 days, and then we end up with this really bad looking uh plot. Okay, okay, so how do we fix this? So very simply, one thing that we could do is uh, increase the size. Yes, increase the size of the chart. So instead of 8 and 4, I want this to be like 20 and 8. This one's much bigger. Yep. Still not really clear. I think 1,000 is a problem. The next thing that we could do is actually end up with uh, an interactive plot. And that is where Plotly will help us. Okay, much better looking. Over like last 500 days, basically, this is what the stock price looked like. I think 250 would be nicer in this case, at least. Yep, there we go. Much nicer. Okay, so we have plotted a randomly simulated stock price over like last 250 days, basically, and that's it. This is a good one, and that is where I am going to put a quick save, and I'm going to copy all of these into session2.py. This goes in here. This goes right below it. Now this is a problem. It says matplotlib is undefined, even though we have actually used it. Okay, this is because we have renamed the variable. So in this case, we'll have to do import matplotlib again, unfortunately. Simple data frame with pandas. This is what we did. Next was using numpy for some calculations. Then we did a figure plotting with matplotlib. So that goes in here. Uh, then there was this mini finance project. And the way I'm going to write it here is in a multi-line comments. Okay, so hash is single line, I'm using multi-line. uh, this is the next bit, the mean, and the whole thing. Actually, I should also do a mean of no sum, mean walk no sum, and a standard walk of no sum, mean of random walk no sum, standard deviation of random walk no sum, and this one would actually be this thing. Okay, and right here comes this one, and this right here, and yeah, there we go. So the mean of random walk with no sum is actually kind of 0, and the standard deviation is more closer towards the 0.96, whereas mean of the random walk after the cumulative sum is this, and the standard deviation is this. Okay, much better, I would say. So let me copy this again. Actually, no, that is fine, right? This is what I need to copy again, because there's slightly changed there, the plot, and similarly the second plot. Let me add a comment. What would be the comment here? Actually, not needed. This is fine. The title should be good enough. If you have to run this in local, what you do is python space session underscore 2. That's the folder slash session2.py. And if I hit enter, you should see some output, but also some stock prices are printed. So there is this one. Okay, stock prices over time, that is printed. I can increase the size of this, decrease the size of this, so all those things can happen. You can save it. Okay, if I close this, then the new one actually becomes visible, the stock price simulation. So in this case, I can increase the size of it, decrease the size of it. If I close it, the third one comes back, like is visible now. Okay, so this is the wrong plot one, and that's it. So once I close all of those, this finally stops. Okay, so if you're using matplotlib, you're running it in Python. The difference is that it will open as a new app slash plot. Then you have to close it for the next one. Close it, close it, close it. That's why Jupyter Notebook is like really helpful, right? You can see all of them together. This is done, and now let me save this again, just because I want to be sure. And let me do a git push quickly of our mini finance project, right? That's what we did. And we learned a few concepts of finance, like what is the cumulative sum, standard deviation, what is variance. Actually, before I do that, kernel restart and clear all outputs. So this ways I will have a clear. Oh, now this one gives an error saying matplotlib is not defined. So I can just do this. Okay, kernel restart and no, you could do restart and run all cells. So that should run everything one after the other. and you should end up at the same point actually. Just that these numbers are then like one after the other. Looks good when you push it. Going to save this, going to commit that, clear it, git add all again, and git commit dash dash amend on the previous one, and git push force. Perfect. So now if you go back here, you should now have a session 2 folder, which should have the IPy notebook with the outputs that we saw, and the Python file with everything again. Okay, any questions so far? You are like 45 minutes into this session. Okay, no questions from anyone, which is like not, sorry, not 45. Did I say 45 minutes? We only have like 45 minutes left, kind of, in this session. Okay, what's next? What do I want to show next? So the next thing that I want to show you is going to be about some real working data. Oops, sorry about that. So yeah, some real working data is what I want to show. Actually, one more thing that I want to show. How do you plot two things over one graph? Yes, let's try that. So normal distribution. Mm, okay, so normal distribution versus cumulative cumulative sum of normal distribution. Okay, so we are going to plot this. So plot normal distribution versus cumulative sum of normal distribution. Step one, you still have to define the size. So in this case, fig size once again, right? Is my screen like erroring for anyone? Or is it fine? I'm confused because for me it stops working. Any response would be appreciated. Is my screen working fine for everyone? That's my question. Okay, plt.plot, and the first one that we have is this one, random walk no sum, and then we have a random walk with cumulative sum. So random walk no sum is what I want to take. Marker is, let's say, dot. Then the line style is a dash. The color is, let's say, orange, and the label is normal distribution no sum, no cumulative sum. Okay, so that's the label of the first one. Similarly, I can actually copy this one and paste it right below, and this one would be random walk. The marker, I want to change that Or actually, let's keep it that. It's the same one. Line style same. The color that I want to change, uh, purple. And this one is normal distribution with cumulative sum. And then let's give the title to the plot. So normal distribution. Actually, no, it's not normal distribution, it's random walk. And this one. So random walk versus a random walk. No cumulative sum. No random walk. No. I'll actually copy this. Okay. Next is the X label, which is, oops, did I? Oh, come on. This was time in days. Then the Y label is supposed to be value. Then we want the legend to be shown. We want the grid to be shown. And let's do a plt.show. And now if I do this, random walk, no cumulative sum, random walk with cumulative sum. So both plots in one. Okay, over like 250 days and stuff. And there's the title, the size, and look at the purple one. That's the one with cumulative sum. That actually reflects the stock price, a real stock price movement. Whereas the one without cumulative sum is just about moving up and down, nearly same across this zero. Okay, so it's slightly going above zero, slightly below zero. And that is what we asked it to create actually when we created that normal distribution. We said that ensure that the average of everything is nearly about zero and the standard deviation is nearly about one for all fit. Okay, so that is how you plot two things in one. And I think this is something that I missed pushing. So let me actually add that in here. So two graphs in one. Also, let me save this one and let me just do a amend and push. Okay, so now this time it should be the exact same commit, but it should now have one additional thing, which is a cumulative sum of two things. In terms of code commits, there have been 5 commits, but in terms of pushes, definitely more than that, right? Okay, next thing. Next thing that I want to show is reading data from, like, reading some real financial data. And I say real because it's actually real. It's the last 1 year data that we want to read from CSV files. So where will we find these CSV files? I will push them on GitHub right now, and you can copy them from there or download it or whatever works for you. Sorry about that. Okay, so reading some real financial data. Uh, Actually, I'll do it in this one only. Let me create a markdown cell and let me add some description. Yes, I think that would be nicer, right? So this one would be called as reading real financial data from CSV files. What will we do here? Uh, Read data read stock price data of Apple, Microsoft, JPM from CSV files. So that's one. Then once we have done that, uh, perform some analysis of the on the data. Okay. Then after that, we are going to merge the data and plot them. So I think this is everything that we want to do, but using matplotlib and plotly. So I'm going to introduce you to a new library, and I think this should be good enough for the next half an hour. Yeah, I think so. So that's this. Now, step one is getting the CSV files. So as I said, it needs to be some real data. So I will show you, add some real data very quickly. In the session 2, I'm going to create a apple.csv, and I'm going to copy paste everything that I have. Okay, so this is the data up till like 7th of Feb 2025, and it started from 7th of Feb 2024. So last 1 year's Apple stock prices, actual Apple stock prices. Next is jpm.csv. Let me copy paste that as well. Same up till 7th Feb, started from 7th Feb 2024. Should be inside the session 2 folder. Yes. And similarly, the third one would actually be msft.csv, that is Microsoft data. And there we go. Okay. So this is the actual Microsoft data, again of 1 year. Let me push all of these so that you can actually get it. I'm going to push it as a separate commit. So git commit -m. This is a feature reading real financial data, working with real financial data. I'm going to do a git push. Don't need to do a git force push anyways. So now if you go in here, go to the session 2, you should have the CSV file. Okay. So this is a nice one. So GitHub is like, actually, we can make it much more beautiful. It looks like row 62 should have 7 columns instead of 2 in line 61. So actually, it's talking about this one. Okay, that this should have 7, but it looks like there is only 2 of it. But that is because dividend was given on that day. So that is why it does not have the high, low, close, adjusted close, and volume on that day. Okay. So what I would suggest is, if you go on this, open a CSV, copy paste this whole thing by creating an apple.csv on your machine if you want it. Or if you have forked it, then all you have to do is very quickly sync the fork. So I have shared the exact link in the chat. Please go there and get the real CSV file. Okay, that is very important for the next bit of the session, which is where we read these files. Okay, I have half an hour, so let me like quickly get into it. Should not be very like, it's not very difficult. It should be able to follow along quite easily. So to read the data, we use pandas. Okay, so I'll create a variable apple, that is pd.read underscore csv, and then you specify the path. Now the path of this, if I reload here, is actually, oh, wrong one, session 2. The path of my apple.csv, jpm.csv, msft.csv is in the same folder. So that is why I'm going to do apple.csv. If let's say it was something like inside a data folder, so I would do like in the current folder, go inside the data folder and then you find it. But for the time being, it's in the same folder. So I'm just doing apple.csv right here. Similarly, we will do jpm pd.read underscore csv. So read csv reads the csv file. Okay, should be pretty obvious now. And msft is going to be pd.read underscore csv msft.csv. So we have done a reading of all the files, which is basically we have the reading is loading it. Okay, we have loaded all the files. Okay, next let's display the data. Now this one has let's see, apple one has around 257 rows of data, which is a lot. So I only want to see the top 5, and there is a way to do that. Display top 5 and last 5 using head and tail. Okay, so I can do something like print apple dot head. Okay, and this should display the top 5 rows. Similarly, if I do a tail, that should display the last 5. So in the last 5, 252 has date, it has the open as some dividend thing, and then high, low, close is not available. So that is why it gets replaced with nan. Let's see. In apple, the last 5 on 254, yes. Oh, 252. It says 255. Okay, so the first one is not a counted one. So then you actually end up with 256 rows. But since the counting starts from 0, that's how you end up with 255 rows. So 0 to 255 is 256. The first one is the column titles. They are not counted in the data. Okay. So on this one, there is a 0.24 dividend, and then there's nothing. So those get replaced with nan, not a number. Okay. Okay. The next one, we could do the same for the others. So if I just copy this one, and I'll also add print apple data and \n. Similarly, jpm and this one, jpm data \n, and this would be msft data, and just copy this one right here. Okay, apple data, jpm data, microsoft data, the top 5 and the bottom 5. Okay, I think that's good enough to understand. Okay, let's move on to the next bit. Now, what else can you get from the data? So you can actually get a summary. Display a summary of Apple's data. So to do that, you can do something like printing it out, apple dot describe. Okay, so if I do this, this is what I get. So it tells me that from the count, the highest value is 252, the lowest is 252. Okay, no, this is the count. Sorry, ignore that. That count is the number of things that you have. The mean and high. Okay, read it this way. Mean and high is 213. Mean, low, this. Close for this column is this. So this one is actually the count of each column. This one is the mean of the high column, mean of the low column, mean of the close column, mean of the adjusted close, and the volume, the mean of the volume column. Then standard deviation of each columns. There is the minimum in the high column. Okay, so in this column, what is the minimum? It seems to be 166.4. So we can go into the Apple dataset and search 166.4 happened in the high column. High is this purple. Okay, so in the purple column, 166.4 was the minimum value for Apple stock. In the low column, 164 seems to be 164.08. Okay, that seems to be the minimum in the low column. This gray, this gray. Similarly, in the close column, in the adjusted close column, in the volume column, then you have the 25th percentile, 50th percentile, 75th percentile, and the max of each of them. So Apple stock price has gone as high as 260.10. Okay, and in the low, like on the similar day, the maximum, the so this is very difficult to actually say it, right? So what it is calculating is the maximum value, which is 257, but this is in the low column of Apple. Okay, so the biggest value in the low column of Apple stock is 257.63. Okay, the biggest value. And the smallest value, is there a way to find the minimum? Yes, there is. 164.08. So the smallest value on the low column is this. Similarly for other columns. So this gives you a summary of the whole data quickly. Okay, you don't have to do much. All you have to do use the powerful describe, and that's it. On data frame, like this comes because of pandas. Okay, that's how powerful it is. Okay, so that's the app description of Apple stock data. Similarly, you could do for Microsoft, similarly for JPM. Excuse me. Also, if you have a question, like I want to see the whole data, you can do this, and some things get lost. So you have to actually adjust it in your pandas features. Okay, so I'll leave that to you. Like, how do you see the whole data in Jupyter Notebook? You have to basically change the setting of pandas and Jupyter Notebook. Now this one, let's say display summary and other details of MSFT data, MSFT's data. So let's see. To get a summary, we can very simply do msft.describe. Okay, that's done. Then you could get something called as a shape of the data. So I'm going to use f strings, and I'm going to say shape, and that is msft.shape. So it says 256 comma 7, where 256 is the number of rows that we have and 7 is the number of columns that we have. 1, 2, 3, 4, 5, 6, 7. Actually, my MSFT. Okay, yes, there we go. Should be the same. 1, 2, 3, 4, 5, 6, 7. Okay, sorry, my bad. Also, if you notice, even though the open column had numbers, it did not calculate the mean, median, high, low of that. Why? Because in between there are these dividend things, okay, which does not confirm to the overall structure of this. Everything should have been floating, but somehow there is a floating with a string in the same column. So pandas ignored it completely. So what we could do ideally is drop those values, which we will see later. Okay, so you can get a shape, then similarly you can actually get the columns. So msft dot columns, you can get the rows, like number of rows, and that is simply like length of msft, right? You can get the data types. Okay, so let's first print all of these. So describe, okay, shape, yes, columns, these are the columns that we got. The number of rows is basically the length. Oh, data types is not length, sorry, this one's wrong. This would be msft dot d types, and that returns that the open one is an object. Okay, high is float, low is float, close is float, adjusted to close is float, volume is float, but open is object again because it does not confirm for the whole uh, column. There are a few columns in there which are which have string values in it. Okay, if you remove that, if you can find and remove that either from the data or programmatically, then this should change to float 64. One last thing is, let's say, how do I uh, find date range? Like, what is the date range of this? Okay, of the data. So you could very simply do MSFT of the column date. So to select a column, you could do dot like square bracket that column dot min of that. Oh, and I'll use a single one here. Yes, because there's a double one outside already. So from min, and then we could just simply do a, like, this is for typing it out, and I'm going to copy paste this to max. So this will tell me the data is from this to this date. So similarly, uh, like why is this helpful? You now know the date range of the data. Okay, just something to check slash know. uh, you can find the unique values. So let's say in the high column, okay, I want to know how many unique things I have. So I can do dot unique. So these are the unique values in the high column of Apple. Sorry, of Microsoft data. I can also do the number of unique values. So for that you do n unique, and there are 245 number of unique values. So the data is actually of 256 rows, but there are only 245 values which are unique. So definitely the high was same on some days, and excuse me. So number of unique values, and those unique values is just this. And I'll also do a backslash n after this and a backslash n before this so that there's space around. So these are the unique values, 245 of them actually. What else? uh, the value counts. Okay, so in this case I want to go through the msft data and go over the low column. Okay, and do what I want to do, a dot value counts. So it returns me which values, like, and how many times. So 420.66 in the column low was two times, 446.41 in the column low was two times, and yeah, so on and so forth. uh, you can do it in any column. So like, let's say I want to do it on the volume column. Everything was only once, not really helpful. So this is to check uh, which values were repeated and how many times. Okay. uh, yeah, I think this should be good enough for everything that we could understand about the data set. Okay, or of the the Microsoft data set. Yes, I want to specify that. Perfect, I think that's good enough. Next, let's actually move to merging the data. Yes, let's do that. So merge the closing prices of each stock based on the date column. This is what we want to do. So how do we do that? We can simply do create a variable merged data, and that is equal to pd.merge. Okay, and now in here I am going to say, for the Apple data frame, take out two of the things, like two columns. One is the date, which is a string, comma, the close. So if you notice, I have two square brackets. Why? I was actually waiting for any answers in the chat. uh, So the two square brackets are basically used to select multiple columns. Okay, we don't have one column, we have two. Similarly for JPM, I will do this exact thing. And similarly for MSFT, I will do the exact same thing. And then I am going to say that we want to merge it, but there needs to be something which should be same across all data set. The dates actually in this case would be same across. Okay, all of them are from 7th February 2024 to 7th February 2025. Okay, so that is why we are going to merge it on the date column. And you can add something called as suffixes. suffixes. Yes, suffixes. Okay, and the suffixes is basically for distinguishing the columns which have the same name. So in our case, let's say I am adding a suffix of AAPL, comma, underscore JPM, comma, underscore MSFT. Okay, that's our merge data. I think this would be a problem. If I remove this, yes. So one problem is that at a time you can merge two things. Okay, so that's why I shouldn't have added this one MSFT on it. So merged the Apple and JPM. Now I want to add to this. So I'm creating like using the same variable again, merge data. And this time I'm going to merge it with the merged data. So merged underscore data, comma. In here, I will say Microsoft with this, and everything else remains the same. So actually, like, just for the clarity of things. So merge data. So first we merge these two data frames on date with these suffixes. Now I'm merging the merged data with Microsoft on date with these two suffixes. Okay, on date with uh not these two suffixes, with just one suffix. Actually, do I really need suffix? Let's see. Yeah, not really needed, because there's only one thing that's getting merged. So this is done. Let's actually uh, print the head of the merge data. This is what it has. So there's close Apple, close JPM, and then there's just close, because I have not added any suffix for the pd.merge. So we'll have to add it. So we have to find the close column, or like rename this to close underscore MSFT. Also in the head, you can specify that I want to see 10 things, and then you can see 10 things. So let's also rename one of the columns, which is merged data equals to pd dot merge. Sorry, pd dot, what am I doing? We want to rename. We want to do merge data dot rename. Rename the columns equals to, we provide a key value. So the key is the original name and the value is the new name. So close underscore MSFT. And then we say in place equals to true. Okay. So that, so in place equals to true. This modifies the original data frame. Okay. So now if I do a run, there we go. The top 10. Top 10 rows. In place modifies, in place equals to true, modifies original data frame. Okay, so this is what we have. Perfect. So now that we have the merged data, let's quickly plot all three of them together. And this time we don't have to do multiple plots. Why? Because they are as a part of the same data set. Okay. So all we need to do is just start with the plotting. Plot the closing prices of Apple, JPM, and MSFT together. So to do that, we know how to plot. We do plt.figure, then we define a fig size. Like at one point, you will remember it from like the back of your hand. 20,15. That's a good size. plt.plot. Now, what do we want to plot? We want to plot the merged underscore data column date, okay, with merged underscore data column close of Apple, and we want to give it the label equals to Apple. Like close of Apple looks bad. and we will say the marker is going to be O. Okay, so this is 1. Similarly, 2 and 3, this is fine. This would be close of JPM, and this would be close of MSFT, and the label would be here JPM, and this would be MSFT, and different markers. So these are the ones that I'm going to use. uh, Title, X label, Y label, yes, but I want to do it quickly, so I'm going to directly go to the legend, and I'm going to say plt.grid is true and plt.show, and this is what I end up with. There are dates here, definitely not visible. Okay, and wow, Microsoft stock prices have been like always much up than Apple and JPM. Okay, I can actually rotate the data, the X ticks, okay, a bit. So I can go like PLT dot X ticks, TICKS, and we can give a rotation equals to 90, and that should rotate the date a bit. Still not really clearly visible. Okay, so this is one problem, that if you have a very big data set to show, uh, and it's not really interactive, it's not really visible, and you'll have to do a lot of configurations actually to make it much more nicer, much more readable. Okay, like let me quickly add the labels and everything. What if I do a rotation of 45? Okay, but not good enough, still not good enough. Okay, so this is where we introduce the we'll introduce Plotly, which is specifically for plotting data that's supposed to be more interactive and visually like better looking. So to do that, we will like let's add Plotly to the mix. I am going to go all the way, like you don't have to actually, you can do it right here. So let me do it right here. So we did download Plotly, so I am just going to import it. Import Plotly dot graph underscore objects as go, and I can also do import Plotly and print the version. So print f strings Plotly. What did we do? Plotly version, is that what we did before? Yeah, version. Wait, sorry. Okay, cool. Plotly version, and that's going to be, so again, since we are going one level inside, it won't be available, the version, so we have to do it from the outside. So that's why I'm importing it twice. I'll write importing again just to show version number. Okay, so this is the version of Plotly that we are using, and by running this we also ensure that, oh yeah, the Plotly, uh, this one, Plotly library is available. So let's plot. So I'm going to actually copy paste this thing. This is what we are going to plot again with Plotly, using Plotly, not with Plotly, using Plotly. So let's create a variable. I'm going to create a fig variable, and I'm going to do go dot figure. Okay, so go is coming from Plotly dot graph objects. Then you do a add trace, add underscore trace. So a trace is like a single set of data in the plot. So we have to add like three traces. We have to add one trace of uh, closing price of Apple, one for JPM, one for Microsoft. So dot add trace. Actually, let me do it in the next one. Trace, and then we are going to use a scatter plot. And I don't think I have much time to explain what is a scatter plot right now. I'll explain it in the third session. But for the time being, before I drop off, I really want to show you the plotted data. So x y equals the merged underscore data of close underscore Apple. The mode is equal to lines plus markers, and the name is equal to Apple. Okay, so this is the first trace, and I'm going to copy paste this two more times. This one would actually be close underscore JPM. Lines plus markers is fine, and this would be JPM. This one would be MSFT, that's the column name, and the name would be MSFT. And that's how we added three traces. Okay, bad idea. Also need to enhance it a bit. I want to do a fig dot update layout, update underscore layout. And in this, I want to add like title equals to closing. What did I have the title here? Closing price comparison. Okay. The next thing is the x-axis underscore title. That will be date. Then y-axis underscore title. That would be like closing price. And the x-axis underscore tick angle. The way we did rotation above, in here we did this x ticks rotation 45. That's the same thing that we are doing here. And finally we do a fig dot show, and then let's run this, and there we go. Rotated 45 degrees, date and closing price, Apple, JPM, Microsoft twice. What? Why? Oh yeah. Okay, perfect. So this is the plot. And if you see this, if I hover over it, actually, do you see how it gives me the data? Like it shows me the data of each day. Okay, what's the date, what's the closing price? But the important part is, as I said, we want this to be more interactive. Okay, so you can use this zoom option, then draw a box around something and keep zooming in the data, and this ways you actually see the data much more clearly, which is important. And you see this disjoint. So between this disjoint is when that dividend was offered. Okay, you can download the plot as PNG. You can pan in, so like basically do left and right into the data, double click to zoom out, and auto scale it, reset the axis if required. But more importantly, I just love the feature of zooming in. So like let's say for like last this, and if you see the data, the dates here, okay, as you keep zooming in, the dates adjust accordingly. Okay, so that's it for this session actually. So I think I can save this, and I will push this after I end the session. But that's all from me for the session 2, the part 2 of finance with Python session. I hope you enjoyed it. Definitely learned a lot about plotting some real data, plotting some fake data, plotting like learning about NumPy, Pandas, Matplotlib, and Plotly. I haven't explained all the functionalities of what I used here in the Plotly, In the next session, the third session that I have in 5 hours, I think. Yeah, in 5 hours, I have the third session, part three of Finance with Python, where I'll repeat what I did here, the scatter plot and everything. And then we'll move to actually working with some more data. Okay. We will write functions to clean data, load the data. We will actually do the OHLC, that is open, high, low, close of everything, plot that data, use MPL Finance and plot candlestick uh, charts, okay, which is what you normally see in any finance website, candlestick charts. So you'll learn how to do all of that in the next session. So that's it from me. If there are no further questions, thank you so much, everyone, for joining. And before I forget, uh, may I again kindly request you all to please fill the feedback form. How did you like this session? Was this helpful? Was it not? What could I have improved? So I've shared the link in the chat for the feedback form. It's a very simple one. If you go on that, all you have to do is select which session you are providing feedback for. So this would be Finance with Python part 2 session. Then give me a rating here. I'm not going to give myself a rating. Uh, and that's it. Like, and some further questions, if any. So that's, yeah, so that's a very humble request. Please do provide feedback to this session. That would help me improve, if any, or I'll understand your concerns better and try and incorporate solutions to them if possible. Okay. Once again, thank you so much, everyone, for joining and hope you have a good day. I'll see you back in 5 hours for my session. But apart from that, uh, the next one, the next GHW session would be with Cecilia, where you will use Figma to code and learn design. Okay. So definitely look forward to it. Figma is such an awesome tool. So join Cecilia in learning how to design with Figma and how to code with Figma, actually. Oh, thank you. Really appreciate this. Thanks a lot. Uh, okay. That's it. Thank you so much, everyone, for joining. See you. Bye bye.